So the sliding filament theory is taking a look at all the steps that are involved in contracting a skeletal muscle, and we also need to take a look at the steps involved to relax that skeletal muscle. And it happens in a chain reaction. It's a step-by-step sequence, and you will need to be able to list them in order. Now, if you take out the notes for this, I have them labeled A through L. I'm going to walk you through using these diagrams, and hopefully this will help out. What we're looking at is the nerve system coming down. It is a motor neuron, so it's responsible. It's a nerve dedicated to moving skeletal muscle. Down this nerve, we're going to find electrical signal. That's what my E with a little negative. Those are electrons. That's an electrical stimulus moving through that nerve. Once it gets down to the synaptic knob, or basically the knob at the end of the nerve, it'll cause a reaction that asks for the release of calcium ions. You want to make sure that you include what Ca2 plus means. It's calcium ions, and that those calcium ions are then going to ask for the release of uh, little neurotransmitters. In this case, these neurotransmitters are called acetylcholine, ACH. Make sure you spell out acetylcholine first, and then you can use ACH thereafter. So the electrical signal will go down the nerve. It will cause the release in the synaptic knob of the calcium. That in turn asks for the release of acetylcholine. You can see in this diagram that acetylcholine is going to be diffusing out of the nerve and moving into the synapse, or that gap between the nerve and the muscle itself. Now, here's where we're going to skip a couple steps other than what your book has to say, but I'm going to just kind of skip ahead, and we're going to say that this acetylcholine basically will stimulate the sarcolemma, the membrane of the cell, and it will ultimately cause a reaction. The sodium-potassium pump will cause a reaction down in the sarcoplasmic reticulum. We're inside the cell right now, and this reticulum is a calcium storage as well. Okay, so we're talking about calcium that stays locked in the nerve, but we're also talking about calcium within the muscle cell itself. So acetylcholine will diffuse out, sensitize the sarcolemma that will ultimately tell the sarcoplasmic reticulum to release its calcium. Now, to get past this stage, what has to happen next, we'll go to the next slide, which deals with the sarcomere itself. We are inside the cell, and now it's working down at the sarcomere level. Now remember that this is called, this level right here, this is the actin, and this is the myosin. We can see these little bumps here on the myosin, and that represents those myosin arms, okay? The myosin heads that are all attached to the myosin and just waiting, okay? Here's the midline. Now the calcium is coming down from the reticulum, and it's going to make its way down into the individual myofibrils and attach to the troponin molecules that are located along the actin. We see it on this side as well. And once calcium attaches to that, it will form a compound and basically slide away the troponin compound, and it'll expose another compound underneath called tropomyosin. The tropomyosin is where the action is. That's going to ask for, basically, think of it like a magnet, where it's going to be exposed, the calcium binds to troponin, it's going to be exposed because it slides out of the way, and tropomyosin will attract each of these myosin heads. It forms what we call cross bridges. Okay, now the muscle has not moved at any point here. All it's doing is forming tension, and basically those are ready to go. Now I'm going to take this guy right here, and I'm going to blow him up a little bit. Kind of show you what he looks like. It's going to have these heads on there like a big paddle. And basically it's just sitting there. Like I said, that's a cross bridge. Now ATP needs to come in. ATP is a battery or an energy source. And once it's processed right there, it's going to cause this head to flex up once, pulling the actin in toward the midline, one notch. So this myosin head will now be flexed like this. But it's stuck there. We still have a cross bridge, another ATP, a second ATP will need to come in and basically work right here and break that bridge, that cross bridge between the tropomyosin and the myosin head. That causes this myosin to go back to its original state, and because tropomyosin is still sitting out there, it's going to attach back up to it. Okay, so it's just going to cycle, and basically it's going to keep on going. One ATP flexes in the power stroke, one ATP will relax it in a recovery stroke, and it's just going to ratchet in one at a time until this sarcomere is completely flexed. Okay, so this is basically what's involved to flex the muscle. Now, we need to go back to the previous slide because on the previous slide we saw this. This is where all the sequence of events that had to happen, this is all what had to happen to get the calcium, to get the acetylcholine, to get the calcium within the reticulum. We have to undo that from the very beginning. So we started with an electrical signal. We have to get rid of that. We want to relax this muscle now. We are now going to step I on your note sheet. We have to get rid of that electrical stimulus. Now that that's gone, we have to basically tell the nerve, okay, I don't want to flex the muscle anymore. Now that that's gone, now the calcium is no longer being released. That's gone. Problem is we still have acetylcholine sitting out here in the synapse. So another neurotransmitter, this one called acetylcholine esterase, that is going to essentially erase acetylcholine. That is going to get rid of the acetylcholine. That's just sitting in the synapse. We can't suck it back up and get it back into the nerve. So this gets rid of, acetylcholine esterase gets rid of acetylcholine. And now there's no more stimulus to release the calcium from this sarcoplasmic reticulum. So now we can actually go through, no more calcium is coming out of the reticulum. That's not happening anymore. So now what we have to do is, remember the acetylcholine, or sorry, the troponin here that sat with the calcium and that covered up, that slid out of the way to expose tropomyosin. Now we're going to pull that calcium off again by the use of calsequestrin. Okay, calsequestrin will cause the calcium to come off of your troponin and go back to the reticulum. So calsequestrin puts it back in the reticulum in the first place. Okay, because this troponin no longer has the calcium, it's going to cover up that tropomyosin, and there's nothing for the myosin heads to stick to. Okay, so that's at the very end. Now all of a sudden the muscle can relax. There's nothing for those myosin heads to attach to. There's no more cross bridges. So that's the full scope of what has to happen to fire a muscle fiber and relax it in the sliding filament theory.